So today the learning targets are that we're going to just talk about degrees and radians, but we're also going to talk about reference angles. We're going to talk about, I will tell you that I have removed this learning target. If we get a chance, I would like to talk about how to do that on the calculator, but basically I removed it from the quiz for the sake of time. I just don't think it's a big priority, so it's gone. If we get to it today, we're going to do arc lengths as well. All right, real quick warm up. Can you review with me? We have the SOHCAHTOA. Are we all good on that one? We got that one memorized? So then what are the reciprocals? Cosecant, which would mean hypotenuse over opposite. The flip of cosine is secant, which would be adjacent over, or hypotenuse over adjacent. And the flip of tangent is cotangent. So everybody's going to have those memorized, right? Okay. Other little warm up here was just review. You have to be able to reduce fractions today. And I wanted to review, even if I just do one of those, like 540. Oh yeah, I already did it on the screen, but over 360. Then if you go to math, number 1 here says change it into a fraction, and it always gives you the reduced version. Okay. So if you had to reduce this on your calculator, because that's a lot of reducing by hand, right? 10 goes in, and then you might say 2 goes in, et cetera, et cetera. It's just a pain. All right. You can also do this on your calculator, or if you were doing it by hand, you would need a common denominator so that you had 1/3 plus 6/3. And then you would get 7/3, and if you had to add another 6/3, you'd get 13/3, etc. Do we remember a little bit about 5th grade adding fractions? Okay. On your calculator, it would be 1 divided by 3 plus 2, and then you would just do that math, enter, enter, and it would give you the 7/3, okay? All right. Vocabulary you are going to need to know. I hope it's kind of review, but when you have an angle in the coordinate plane, we are going to always put the initial side that we start measuring from on the positive x-axis, and then we are going to measure or rotate in a, is that clockwise or counterclockwise, guys? Right, the clock turns this way, okay, which you guys at least know. In a few years, I'm not sure students will know that, because everybody's going to digital clocks. But counterclockwise is a positive direction. And then wherever you decide to stop, that is called the terminal side. In other words, where you stopped, okay, you ended. And before we go too far today, we do need to review that this is quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. Normally they use Roman numerals, but I'm fine if you don't, okay? No big deal. All right, so real quick on your notes, an angle on the coordinate plane is in standard form when the vertex is at the origin and one ray lies on the positive x-axis. The ray on the positive x-axis was called the initial side. And the other ray, wherever it may be, is called the terminal side. Counterclockwise rotations result in positive angle measures, and clockwise rotations result in negative angle measures. So if we decided to go this way, anybody tell me what that would measure? Right, -90. Good job, guys. I didn't ask that question very well. But when we rotate this way, it's negative. Is everybody okay? Before I spend 10 minutes explaining something that you do understand, I just didn't ask the question well. All right, the most common unit of measure for angles is degrees. I guess it says the degree. A degree is equal to what part of a full rotation? In other words, how far does it take to go all the way around in degrees, guys? 360. So it is 1/360th of a full rotation. It's a really weird way of just saying 360 is all the way around, okay? And then we have to talk about radians. I would like to give you, I'm skipping all this. If we have time to come back to it, great. If I were to lay down, let's see, let's go with red. That's the radius, right? If I were to measure exactly the same distance at a little bit of a curve around this, so that this radius is the same as this, which is actually called an arc length, the angle it took to get there, okay, is a radian. So, how far is it all the way around in radians? Well, do you remember this formula that the circumference of a circle is 2 pi r? Does that sound familiar from geometry? So if r is a radius, it's also a radian, so it is 2 pi radians all the way around. If we started here and we measured all the way to here, that would be 2 pi radians of rotation. So what would it be to go to here? 1 pi, right? We okay? Halfway around the circle would be 1 pi radians. Okay? So it would be, if I took my radius, I'd get to 2, and then I'd get to 3.1 of these. Okay, the third, okay, so there'd be 3, and then 0.1 of them starting for the next radius. Because at 3.1 of these little radiuses is when you would hit 180. All right. How many of you know a foreign language? Or a little bit, even just you've taken like a semester at least? Okay. How many of you still think in English? Everybody, probably, right? Unless it was your first, if your first language is something other than English, then you may not think in English. My brain thinks in degrees, not radians. Does that make sense? When I see a radian problem, I translate it into degrees because my brain does not do well in radians. So it's okay, but we have to know how to do that translation. So the translation we're going to work with is that 360 degrees is really 2 pi radians, and that makes 180 degrees 1 pi radians. Now, I can write the word radians here, but I gotta tell you, radians is this magical label that they will not label things often and assume it's radians. I have a little slide that says that here. It says, if no units of angle measure are specified, radian measure is implied. If degrees are intended, it will have the little degree symbol. All right, so back here, it's just, do you guys call this dimensional analysis when you do things like 1 mile is, if I said I had 7 miles and I wanted to say 1 mile is 5,280 feet, so the miles cancel, or you use it in chemistry and you cancel out moles and grams and all kinds of weird stuff. Is it called dimensional analysis in your class? Okay, so that's the way I think of radians and degrees, is it's just a dimensional analysis problem. So if I have degrees, I put the 180 degrees on the bottom so that it will cancel and I'll be left with radians. If I have radians, I put the pi radians on the bottom so that that will cancel. But the conversion I always use is this guy, that 180 degrees is equal to pi radians. So, you have these two examples, I think. But this one said 36 degrees, so I needed to get rid of the degrees. So I put the 180 down there and the pi radians up here. And they don't usually even bother with the word radians. Then the degree symbol cancels. I'm left with radians. And 36 happens to reduce into 185 times if you do it on a calculator, so you get pi over 5. This one said negative 17 pi over 3. This was already radians, so I'd put pi radians in the denominator, 180 degrees up here. The pi radians would cancel. 3 goes in here 60 times, so 17 times 60, I assume is 1020. Because this one came out negative 1020 degrees. All right, so let's practice. If it is a negative, you don't do anything different, you just leave it negative. So you're going to get rid of degrees by putting the 180 degrees in the denominator and the pi radians on the numerator. The degree symbol will cancel. I think we can just knock off the 0. I don't think it reduces past 25 over 18. Does that seem right, guys? And then there's a pi. So that's the exact answer. It says write each degree measure in radians as a multiple of pi, so they don't want a decimal. Did I explain that badly, guys? You could have literally typed negative 250 divided by 180 and do the whole math, enter, enter, and it would say negative 25/18, and then the pi is still there, and they want us to leave it as a multiple of pi. All right, so one more. You want me to do 2 or 3? Nobody cares? I'll do 2 then. If you multiply by pi over 180 degrees here, 6 goes into 180 30 times, I think, so you just get pi over 30. And you don't have to label it radians. That's the understood label. You can do the 871 or skip it, I don't care. I'm going to go and do a couple that are in radians now. So negative 7 pi over 9 has no degree symbol, so we have to assume radians. Just because it has a pi doesn't mean it's radians. I'm not going to trick you ever. It's going to be radians if it has a pi. You would cancel the pi radians down here, and that would leave you with 180 degrees times 7 over 9. And it's negative. You can type negative 7 divided by 9 times 180, but I believe it's going to be negative 140. And I did that in my head because 9 goes into 180 20 times, and 20 times 7 is 140. So can you do 5 on your own? And then we'll talk about 6, because 6 is weird. Anybody get an answer? Yeah, I got 78. Is that what somebody said? Okay. Now, the weirdness is that this doesn't have a pi, but it's radians. Does anybody need me to talk about number 5? Was it 5? 13 divided by 30 times 180 would do it. Okay. This, oops, I already messed up. This is already in radians, even though it doesn't say there's no degrees, so it's in radians. So I need to get rid of radians, but there's no pi that's going to cancel. But still, I know pi radians is 180 degrees. So 1 radian cancels out with radians down here. I am left with a negative 180 over pi. And that is all in degrees. Does that look like a good time to change to a decimal to you? Can we do that? Negative 180 divided by pi at negative 57.3 degrees. By the way, doesn't matter that it was negative. That is the amount of degrees that is approximately equal to 1 radian. Okay, about 57 degrees. Does that make sense that it goes into 180 a little over pi times? Okay, 60 times 3 would be 180, so pi is pretty close to 3. All right, then we need to talk about coterminal angles. This vocabulary, coterminal, means ends in the same place, or the terminal ray lies in the same place. So if I made up a number for this, let's say it's past 180, let's call it 232, just to be weird, okay? Let's say that's a 232 degree angle. Could you find this negative angle that went the same way? What would you need to do? What do they add up to altogether? The whole circle. So if you do 360 minus 232, or 232 minus 360 would actually be better, but I don't know, guys. I picked a number I can't do in my head. 128? Is that right? Did somebody type it? Okay. But it's going in the negative direction, right? So it's negative 128. I should just picked an easy number, Hofbar. That was ridiculous. Okay, let's pick an easy number on this one. If I picked that that's a 60 degree angle there, going this way, this alpha one here, I'll do that in green. What would it be if you did this? You went all the way around, still in the positive direction, and landed at that same spot. You would take that 60 and do what? Add the all the way around part and get 420 degrees. Coterminal means they end in the same spot. It can be positive and negative, or it can be positive and positive, or negative and negative. If it's degrees, though, all you're doing is adding and subtracting what? You want to keep giving a new name for that angle. Okay, it's 60 here, but I want to go all the way around once and get to 60, or I want to go the other way and get to 60, or I want to go around twice and get there. I just keep adding and subtracting 360 degrees, yes? If it's in radians, what would you keep adding and subtracting? What's a whole revolution? 2 pi? All right, so coterminal angles mean they end in the same position. If they are degrees, you will say you add or subtract 360. So they use this symbol for some reference angle. You can just say an angle. And I would say you add and subtract 360. N is an integer. Integers can be negative. Okay? ... Integers can be positive or negative. That's why they just say you can add 360 times n, because you could add 360 negative 2 times. To remind myself that it can also be negative, I just put plus or minus. All right. Do you guys, when you did these in trig, do you remember if she did plus or minus or just did plus? Plus or minus? Yeah. Okay, if it's in radians, you would take the angle and add or subtract 2 pi n times, n being an integer. And you can't do it half a time, you have to do it a whole multiple of 2 pi. So this idea is kind of weird, and we don't use it at all on the first quiz, okay? You do the idea in little pieces, but you don't do the whole name all thing until later in the course, but it's on here. If you wanted all the angles forever that are coterminal with negative pi over 2, you would say negative pi over 2, and you would add or subtract. What is that measure in right now, guys? Degrees or radians? Radians, so therefore I need to add radians. What is the multiple for radians? 2 pi is a revolution. And you would say n, where n is any integer. Can't spell integer apparently. I will not make you write that, any integer part, but just for your notes today, I'm going to write it there. All right, 135 degrees. Well, you would add or subtract what? Instead of 2 pi, you'd say 1 revolution in degrees would be 360 n. And usually we put the degrees, but I'm not going to be picky. And this one's back to radians, so you'd have, is that a 5 pi over 3? Okay, I don't know if I said this yet, but I rolled over on top of my glasses and broke them in 3 pieces this morning, okay? So as long as you pretend to be paying attention, I'm going to have no idea what you're doing out there. I cannot see anything, okay? I have my reading glasses on so I can kind of see the screen here. So just fake it and you'll be fine today. All right, bow tie. I don't know if Miss Oren talked about this if you had her for trig, but the rule is, okay, let me go to this slide. It says for any angle in standard form, the reference angle is the positive, it's got to be positive, that's very important, positive acute angle formed by the terminal side and the x-axis. Doesn't have to be the positive x-axis, either branch of the x-axis. Because we can only go this way, or this way, or this way, or this way, we say the triangles that we use will look like this, or this, or this, or this, and those are all going to make like a bow tie if we did all of them, okay? What I'm trying to say, guys, is if you draw a triangle, it's never going to look like that. You see what I'm talking about? It's got to be with the x-axis. That's why I call them the bow tie triangles. Okay. So 150 degrees would rotate past 90 and stop over here somewhere. And so we're to sketch it. But we're also to find the reference angle. The reference angle is the positive angle it makes with the x-axis in here. So in this particular quadrant, how would we find this angle? If this is 150 degrees, how do we find the little angle in here, guys? Yeah, this is 180, right? So 180 minus 150 makes that little angle in here 30 degrees. Please tell me that's not as tricky as you made it sound by not answering. Are we okay? Okay. 315. Well, this one's 90, which makes this 180, which makes this 270. So 315 is passed there into this quadrant somewhere, right? Okay. If that's 315 degrees of rotation, I need to figure out this little piece. Okay, how do you find that little piece? Yes, it's the rest of the way to 360. So 360 minus 315 is 45 degrees. It has to be an angle less than 90, and it has to be positive to be the reference angle. And it's got to be with the x-axis. That's most important. Negative 240 is going this way. Negative 240 went past negative 90, past negative 180, but not to negative 270 yet, right? So it's somewhere up here. Negative 240. What quadrant is that in? Because that's going to be on the quiz. That's quadrant 2. Okay. We need to measure it back to here because it's got to go back to the x-axis. So this was the 180 line. How far did we go past 180? 60 degrees, yes? You could add 180 to this, but it would give you a negative 60. The reference angle is always positive. Okay, this is the 180, and you went negative 240, so the angle in there is 60. I don't want to spend a lot of time explaining how you could do that. It should make sense. That's got to be positive. Okay, and by the reference angle, that's the little symbol I'm using, the little theta, or alpha guy, sorry, alpha. All right, unfortunately, I would love to teach you how to do all of these in radians, but I think you would be very confused, especially since it's your first day doing radians. So I'm going to talk about them in degrees. Remember how earlier I talked about translating? We're going to translate this. So you're going to change this by putting pi 180. The pi divides out. This will become 300 degrees. Now, if I change it to 300, do you know which quadrant that's going to land in? 90, 180, 270. It's over here somewhere, right? 5 pi over 3 was 300 degrees. All right, so what is the angle in here, guys? The rest of the way to 360 would be 60 degrees. And then you have to answer as radians. So if you went back and did the whole, how many times does 60 go into 180? 3. So it's a pi over 3 is what they're really looking for as your reference angle. If they ask it in radians, you need to answer it in radians. I'm sorry to say. All right, I'm going to do another one, but I can do both of them real quick, but can I talk you through how you could do this in your head without touching your calculator maybe? Pi is really the same as what? 180 degrees, right? 6 goes into 180 how many times? So this is really 7 times 30, which is what? 210 degrees? Some of you are already reaching for the calculator. Okay, so 210 goes past 180 somewhere into quadrant 3. And to figure out, we need to figure out how far past 180 it went, because that's our angle back to the x-axis. So if we subtract 180, we get 30 as the little reference angle in here. Did that help anybody by talking through that way? Anybody? Pi is to here, right? That's 180 or pi, guys. When you divide it by 4, what are those in degrees? 45. So every one of those is halfway there is a 45. So -5 of these would go -1, 45, 2, 3, 4, 5. So -5 pi over 4 lands me right here. It is in quadrant 2, but it went this way. So can you guess maybe the reference angle in radians back here? How much is that little angle? If it was, they're all 45s, right? So this is a 45 back to here, so it's a pi over 4. All right, I'll do it the long way real quick. If you have -5 pi over 4 times 180 over pi, you would do -5 times 180 divided by 4. Is it -225? Did someone type that? Okay. And then you just want to know how far past 180 it went. So if you add 180, you get -45 degrees. But remember, the reference angle is always positive, so it's 45 degrees. And if you multiply that by pi over 180, you get pi over 4. All right, I'm hoping these will become easier. All right, quadrantal angles. These are not, if you land on 0 or pi over 2, which is halfway to this, or in radians, this would be pi, or down here in degrees, it would be 270. If you land at any of those, they're called quadrantal angles. They're not really called quadrant 1 or quadrant 2. It means they're on the quadrant line, okay? I'm going to skip that slide and talk about that in a second. I want to go to these questions. Can you go to 7 and 8 real quick on the bottom of that page, the next page maybe? I'm actually going to start with number 8 because it's nice. The numbers come out nicer. It says the given point lies on the terminal side of an angle in standard position. This is number 8 at the bottom of what page, guys? What is it? Oh, it's number 11? Oh, it's number 11, but it's on 8A. Okay, I'm sorry, I just didn't hear what everybody was saying. This is numbered 11 on yours? And what, is this one numbered 10 then? Okay, thank you. We didn't do these in second hour, or we didn't do them on the worksheet because I was doing them on the whiteboard as fast as I could. Okay, so if we plot an ordered pair, I'm not going to try to, it's over here somewhere, right? Negative 12 to the left and up 5. Okay, how do we connect it back to the origin? And where's the angle we're going to talk about if that is our terminal side? It says the terminal side goes through that ordered pair. I have to draw a bow tie triangle to the x-axis. Is everybody okay with that? That's the triangle we have to talk about. It can't be this one going this way. Then we put our little alpha or theta, whatever you want to use, down there in that corner. That's the angle we're going to talk about. They use theta in the directions, I guess I should call it. Well, actually, this is officially theta, and that's alpha. It doesn't matter. It's the same for finding the trig functions. Okay, we went, everybody make sure this makes sense to you. We went left 12. Does that make sense? And up 5. So our triangle has a negative 12 and a 5 for the sides. Normally, you can't have negative numbers on the sides of a triangle, but we're in the coordinate plane. That being said, this radius or hypotenuse is always given a positive number. Okay, how are we going to find that positive number? Pythagorean theorem. Good job. When you square negative 12, it will become positive. So if I were you, I just wouldn't bother with the negative. 5 squared plus 12 squared is 169. Anybody know the square root of that? Okay, so this side turned out to be 13, which is why I picked to do this one, because the rest of them are radicals. This one comes out nice. All right, then we need to do all those silly sine of theta, cosecant of theta, cosine of theta, secant of theta, tangent of theta, and cotangent of theta. Okay, they're really easy on this one because there's no reducing or rationalizing ugly square root denominators. So from this angle, this would be called opposite, this would be adjacent, and this would be hypotenuse. So is opposite over hypotenuse. So it's 5/13. Is this an X or a Y, guys, that 5? Because eventually you're going to have to know this as a different definition. That's a Y value, right? Because it was an up and down. So eventually we're going to call that Y over R, where this is the radius. Okay, we flip it over and we get 13 over 5. But that was positive. Cosine is adjacent over hypotenuse, so we get a negative 12 over 13. Secant is the flip of that, so it's also negative. Doesn't matter where you put the negative, top, bottom, or in the middle. Tangent, opposite over adjacent. Can someone give me that one? Negative 5/12 or 5 over negative 12, however you want to write it. And cotangent, then you would flip that over. Okay. Unfortunately, they're not all that easy because we got that disgusting rational rule about radicals. Okay. This one, what quadrant am I going to draw that in, guys? 2, -5. Yeah, 2 to the right and down 5. So this ordered pair out here would be 2, -5. Everybody okay? We have to find the hypotenuse, which isn't going to be pretty. 2 squared plus -5 squared. Again, you can just leave off the negative. It is 25 and 4 is 29. So the square root of 29 goes here. Did I lose anybody? That was just Pythagorean theorem. I can't stress enough, you either have to use parentheses around the negative number or just forget that it's negative, because it's always going to become positive when you square it. Okay, so using this angle, we have opposite, adjacent, and hypotenuse, or x, y, and r. We'll use those definitions eventually. All right, somebody tell me sine. Is it nice? Opposite over hypotenuse is not nice. It's -5 over square root of 29. Okay, you multiply by square root of 29 over square root of 29, and you end up with -5 square roots of 29 over plain old 29. I'm going to stop showing that step in the middle there soon. We have to do the reciprocal of that? Well, is there an easier place than trying to flip that last answer over? Can we flip it over right here? Remember that was opposite over hypotenuse. Couldn't we just do hypotenuse over opposite and we'd be done? Square root of 29 over -5. If we flip it over, we're going to have to rationalize it all over again from here. All right, cosine. Well, cosine is adjacent over hypotenuse, so this time it is positive, but it's 2 square roots of 29 over 29. Can I just say that that would become 2 square roots of 29 over 29? When you multiplied top and bottom by the square root of 29? Okay, so what happens when you flip it over and you have secant? Go back to here and flip it over. What would it say? Square root of 29 over 2. Oh, we get some easy ones. Tangent, opposite over adjacent. Anybody? -5 over 2, which makes cotangent -2 over 5. Okay, I do hereby solemnly swear you will not have to do all 6 trig functions for me on a quiz, okay? I'll ask you to find like 2 of them. All right, I want you to back up for a second, and I want to talk about what happens in each quadrant. The quadrants are numbered 1, 2, 3, 4. In this quadrant, both the x and y values are positive. Does that make sense? So anything I do in that quadrant is going to have positive results. There's no negative numbers. So all 6 trig functions are positive in quadrant 1. All right, if I move into quadrant 2, going up is still positive, but I go left for any negative x values. So when I draw my triangle, this is always going to be a negative number. This is called an adjacent. Which uses A, guys? Cosine uses A for adjacent and tangent, yes? So the only thing that stays positive is the sine. So the sine is positive in quadrant 2. What else? What's the flip of sine called? Now, it seems like in quadrant 3, everything should be negative because both x and y are negative, right? This is a negative and going down is a negative. But if you do opposite over adjacent, that's going to be a negative over a negative, right? So tangent will become positive. And what's the flip of that? Cotangent is positive. All right, if you get around to quadrant 4, this time you are going down, but the x or the adjacent is positive. So what has a opposite in it that would become negative? Sine would become negative and tangent would become negative. So the only thing left positive, because it has only adjacent and hypotenuse, is cosine is positive. Cosine and secant are positive. Okay, back up a minute. these were all positive. So the phrase that teachers use to remember this is all students take calculus. Not true, but it's amusing for math teachers. Are you looking for somebody? Yes, Raina. Okay, all students take calculus. Now, the only reason I remember it that way is because you're going this way. Could you spell X like ACTS if you went this way? That might be easier for you to remember, but in my brain, the quadrants go this way, right? So either way, but you got to know what that stands for. It stands for all are positive, only sine and its reciprocal are positive, only tangent and its reciprocal are positive, and only cosine and its reciprocal are positive. So this stands for what's positive, okay? Not negative, what is positive. All right, how much time do we have? Okay, we can get through these 4 questions and we will leave. That means we're not going to get to talk about arc length today, okay? But if you do the delta math tonight and you get to the arc length questions, just stop, okay? I think they're at the end, or skip them. All right, this says cosine is greater than 0. What does that mean, guys? Greater than 0 means positive. Which quadrant or quadrants could it be in if the cosine is positive? What does it say up top? Quadrant 4 and quadrant 1, right? Okay, if tangent is, what is this? Tangent is less than 0, so tangent is negative. Okay, tangent is positive in 3. They're all positive in 1, so where would it be negative? 2 and 4. Okay, what does this one say? Secant is less than 0. That means negative, right? Less than 0 means negative. Secant is a flip of cosine, so cosine is also negative. So where would it be if the cosine could be negative? 2, because only sine and cosecant are positive. And 3. And the last one, I think we might be down to 1 quadrant. If the sine is less than 0 or negative, and the cotangent, which means tangent also, is positive. So cotangent is positive is in 1 and 3, right? Because tangent and cotangent. So where would the sine be negative then? 3. Hey, you have to memorize a lot of stuff for this unit, okay? How we doing? This is the assignment. It's in Delta Math. It's called Radians, Reference Angles, and More. And the more is some arc length stuff that we didn't get to. I didn't plan very well, but we're doing fine. I have a work day built in next week, so if we get a little behind, we'll get caught up before the quiz.